Alright, please excuse the wacky camera angle. I'm trying to keep my gut out of the frame. Okay, yesterday when we were in class, somebody was asking about going over the stuff that's going to be on the test. Now, on Blackboard, there is a list of pretty much everything that you're going to see on the exam tomorrow or Tuesday, whenever you choose to show up for it. But I wanted to go over a few things, and this is all stuff that you've seen before. Okay, AEC, which sometimes we refer to those things as photo timers. Go back over AEC. What they can do, what they can't do. Remember that positioning is important with AEC. All they do is control the time, right? And remember that, okay, when you're using an AEC, if you make any changes to the KVP or to the MA, that's really not going to have a big effect on your image because the computer is going to just change the time on you, right? So the only way to increase or decrease your density is to use that plus and minus density control. Also remember why we use regular cassettes in the Bucky. If we use an extremity cassette, we're going to get underexposed, and we've seen that in the lab a couple different times when we accidentally put an extremity cassette in there. And also remember your KVP. You can raise your KVP, not a problem. It does have some influence on your image. So if somebody says, hey, am I going to lose contrast by going to 100 KVP? Yes, technically. But is it going to be enough to make a big difference diagnostically? Probably not, especially since the physician can just change the window width, and he can take away that change in contrast totally or enhance it, whatever he wants to do. Remember that with your, anytime you're doing an exposure, the lower your time is, the less risk of motion blur there's going to be. And you guys all know this. Whenever we're doing chest x-rays, we use like 3 or 4 milliseconds, and that effectively lets us do stop motion photography of the heart, which is always in motion. Remember that whenever we're in the hospital, wherever we're working, it's not up to us to repair the equipment. If your boss ever says, hey, grab a screwdriver and go fix that generator, yeah, we don't really have the training for that. That's not our bailiwick. We can test the equipment, but if we need somebody to fix it, we have to call for help. Let me see. Remember that stuff we went over back in the semester about repeat analysis, reject analysis? What were the most common causes for repeats? And what do we use that analysis for? And it should not be used to fire people. And remember the tools, okay? All those tools we used, and I think those were on our first PowerPoint. We had a list. It was like, the step wedge penetrometer, the spinning top, the sensitometer, the densitometer. Go back over those and know what each one of those things does, because you don't necessarily have to know how they work. You just need to know what they are and what they do, in general terms. Let me see. Oh yeah, go back over all those numbers we hit yesterday. The base plus fog. Remember that base plus fog should never be over 0.25. Speed point is base plus fog plus 1. Go back over your Dmin, Dmax, and contrast index. Hopefully everybody's got a handle on those things. DR and CR. Remember the stuff we went over on those. The signal to noise ratio, the modulation transfer function, the size of the pixels, what determines the size of the pixels with each one of those systems. And let's see, what else? Film screen contact. The wire mesh test helps us with film screen contact. That's the only thing it does. The Wisconsin test cassette helps us measure KVP. The STAR test pattern and the bar pattern and the pinhole camera, remember those all help us test the focal spot size. Let me see. And you guys know what window width and leveling is. Remember the stuff that influences spatial resolution, and you guys probably remember SID, OID, focal spot size. Those are really your primary determiners of spatial resolution. Oh, also patient motion. Patient motion will totally ruin your spatial resolution. Static artifacts. Compensating filters. What do we use a compensating filter for? It's primarily used to even out the exposure to the image receptor, not necessarily the patient. Optical densities. Every change of 0.3 is a doubling of the density. Remember that. What would be a change of, say we had 0.9? What kind of a difference would that be? I'll give you a hint. It's either double, quadruple, or 8 times. Remember the difference between quality control and quality assurance. Quality control, we're testing our equipment. Quality assurance encompasses more than that. It also includes stuff like wait times, whether or not your technologist was smiling at you, they remembered to do all their ADAT, including the thank you at the end of the examination. Thank you very much for your examination today, and we hope that you'll remember our facility for all of your future imaging needs. We want repeat business. Some days you're going to feel like you don't. You're going to never want to see these patients again. But trust me, you want them to come back over and over again so that you can keep your job. Total filtration for diagnostic X-ray has to be at least 2.5. More is better. Let's see, manual spinning top, synchronous spinning top. What's the maximum deviation we can have for KVP? I'm not going to answer that. I'm hoping you remember it. Okay, timer accuracy test. If we're using a manual spinning top, I know, but pretend like we've got a manual spinning top and a single phase generator. Okay, so suppose we spin that top and we've got a full wave rectified unit. So we should have 120 pulses per second. If we count 30 dots, then how long was that exposure? Well, you can figure that out. All you got to do is say 30 over 120 and then reduce that fraction and you're going to come up with 1/4 of a second. Okay, 30 dots, 1/4 of a second. That was easy. But if we use that manual spinning top with a high frequency generator, what is it going to look like? Just an arc, and since it's a randomly spinning, because it's a manual spinning top, that means that it's totally useless. We can't use it at all. And why would we? We can just reach for a digital measurement device, right? And it tells us exactly what our exposure time was. Okay, reciprocity. Don't forget what that is. Reciprocity and reproducibility are different. Reciprocity means that we can increase our MA and decrease our time. As long as the MA times time comes out to be the same mass, then those images should look the same. So that, for example, that allows us to do a breathing technique. We can drop our MA and increase our time and just let the patient breathe normally and do something like a transthoracic shoulder, and it kind of blurs out the ribs and makes it look good. Okay, let me see what else is on here. Okay, I'm going to show you guys some x-rays, and you're going to have to figure out what kind of test is going on there. Hopefully you're going to be able to identify those. And, oh yeah, collimation. What does collimation do for us? Well, when we collimate down to the part of interest, it saves dose to the patient, important. It also helps our contrast by reducing the scatter radiation. So it actually makes our image look better. Collimation is always a good thing. Okay, remember that the exposure indicators, they don't indicate how much exposure the patient got, they indicate how much exposure the image receptor got. So if you've got a big, huge patient and you've got, X amount of exposure to the image receptor, the exposure to the patient could have been like really, really high because we had to penetrate all that tissue trying to get to the image receptor. So if anybody asks, The exposure index, that just tells us what the image receptor saw. It does not tell us really anything about what happened to the patient. Now, there are some companies out there that do something called a dose area product, and what they do is they think, okay, well, what is the average size of a patient? Okay, well, for a patient this size, if this much energy hit the image receptor, then how much energy must have hit the patient? It's not accurate. It's only a guesstimation. But it can help. You know, some places now are tracking patients' dose on, like on their chart. And the reason they do that is because some of these patients are coming in over and over again for not only flat film x-rays, but also for CT scans. Anode heel effect. Remember what that does. And when you're looking at the transformer, remember for the x-ray tube, we need a high voltage transformer. That's a step-up transformer. We also need a rectification circuit to turn the high voltage from AC to DC. We also need a filament circuit, which uses a step-down transformer. We also need an auto transformer so that we can regulate our KVP. So a lot of different parts go into what we call the generator, the transformer box. Got a lot of equipment in there. Remember that with the anode heel effect, the smaller your anode angle and the smaller your effective focal spot, the more anode heel effect you're going to have. There's nothing we can do about it. Okay, what is the HVL for a human being? I'm not going to tell you. I'm going to ask you on the test. PBL. Okay, remember, for manual collimation, we have to be accurate to within 2% of the SID. For automatic collimation, that's the PBL. That's a machine, and it has to be accurate to within 3% of the SID. What does the HVL test do? Let me see. Oh yeah, and variances. Remember, for reproducibility, we're supposed to be accurate to within 5%. For reciprocity, it's 10%. And for linearity, I think it is also 10%. Go back and look at those. You know, so if I tell you some numbers, you can tell me if they're in or out of bounds. Remember, with most of these QC tests, what are we looking for? Consistency. We just want to make sure that our equipment is performing the same today as it was yesterday and the day before. And if there's any major fluctuations, we got to figure out what's happened. Okay, first thing we do is retest. Then if we retest and we still see the wacky results, then we call for biomed guys to come in and we tell them what's up, and then they test it. Because of course they're going to think we messed up, right? That's going to be the first thing is, well, what did you do? What'd you do? What'd you screw up? Nothing. Sometimes we have to, you know, convince them that it's not our fault. Okay, let's see. We already went over star pattern, warm-up technique. Okay, if you don't warm up your tube, what could happen to it? Well, theoretically, if you hit it hard without it being warmed up, it could crack, maybe. Now, if the bearings give out, this is something that happens from time to time. It's pretty rare because these bearings are tough, you know, they're built to last. But if your bearings do give out and your anode is not spinning like it should, then you could wind up with pitting or melting of the anode. Okay. All right, so that basically is me going over the test with you. And go back to Blackboard and look at, you know, go back over our PowerPoints and, you know, kind of pay attention to the numbers. Anything that in class I said, you know, because usually when we're going over stuff, I say, write this down, remember this, because you're going to see it on another test. So if you've got those things down, then you're probably going to be fine. And you guys are pretty smart anyways, you know, everybody in here's got a high grade, relatively. I think everybody's got an A or a B for this class. And yeah, you guys have done really well. All right, so study and good luck. And I will see some of y'all tomorrow morning at 9 o'clock. That's Thursday. And then anybody that doesn't show up tomorrow at 9, I'll see you next Tuesday at 9 when you've got opportunity number 2 to take this examination. All right, have a good afternoon. Talk to you later.